Hey guys, so forgive my low-tech drawings here. They're all done by hand and I didn't even have my good compass. So I'm going to go and do a quick review over units 12.1 to 12.6, lots and lots of circle theorems, and then you guys should be able to even watch a couple problems get worked out. So I want to do a quick review of all of the formulas that you should already have and all of the theorems that you should have written in your notes. First, in this one, remember we had lots of theorems that dealt with tangents to circles. And one of the first ones said that if you have two lines which are tangent to a circle and they intersect at a point outside that circle, then the lines are the same length. So for example, if in this case, like this one is maybe line number DAW, right? We know that the length of DA would be equal to the length of DW, because they're both tangent to that circle, and so that means that they have, since they intersect at a point outside, it means they have the same length. So also, if you have chords or angles that are formed inside of a circle, so for example in this one, this AOB and COD, these two are the same angle measure here. So if we know that those two are the same angle measure, then we also know that the arcs that they form are the same length. So on this one it would be arc AB is congruent to arc CD. And then also on top of that, those chords are also the same length. So that would mean that chord AB is congruent to chord CD. So that gives us a nice place to go from there. When we're down here looking at angles that are inside of a circle, so we also can make a connection between the arc measure and the angle measure. In this case, the measure of angle B is going to be equal to, I guess I shouldn't use congruent, I should use equal to, the 1/2 the measure of the arc length. So in this case, it'd be 1/2 the measure of that arc length AC. So this angle would be 1/2 this arc length here. So moving on to the next one that you should realize, if we have two chords that are intersected here, in this one, to get the measure of this angle here, what you'll actually do is take the sum of the two arc lengths, add them together, and divide by 2. So essentially you're finding the mean of the arc length, and that will be the same as the measure of angle 1. So we're going to go ahead and say, so the measure of angle 1 here is going to be equal to 1/2 the two arc lengths put together. So I measure this arc length, this one, add them together, divide by 2, and that will give me the measure of this angle 1. Now, if instead of intersecting inside the circle, your arc lengths are intersecting outside of the circle, then you actually perform the same calculations except that you're subtracting. So on this one, for the measure of angle 2, it's going to be equal to, again, 1/2, but instead of the sum of the two arc lengths, it's going to be the difference of the arc lengths. So I'll take the arc length of y, subtract the arc length of x, divide it in half, and that'll give me the measure of this angle 2 that's here outside of the circle. And then as we're working through those, the last set that I want you guys to be thinking about and have written in your notes are looking at segment lengths. So remember we said that if you have two chords that intersect inside of a circle, like this is AB and CD, then the product of A times B will be equal to the product of C times D. And that's a nice way of being able to solve for those arc lengths inside a circle, if you have chords inside a circle. If you instead have two secants which intersect at a point outside of the circle, then it's a little bit different. That formula, you should remember, says that you take the whole length of the secant times the part outside. We sometimes call that whole times part, and that will give you the same on the other. So the whole times the part, the product of those two. So remember, it's whole times part outside, and whole equals whole times part outside. So we can go ahead and use that one also to be able to find or solve for the secant links in different circles. The last one up here actually kind of combines some of the ones before. If you have a tangent and a secant, you can go ahead and know that the square of the tangent is equal to that same similar formula, the whole to the part. So Q plus P times P is equal to the tangent squared. Then the last part that you should have in your notes is this little piece down here that talks about a circle. And so remember that if we have a circle that is inside of the coordinate plane and that its center is at point HK, its radius is R, and then any point along the circle is at XY, then we can use that general form of a circle, which is x minus h squared plus y minus k squared equals the radius squared. And then this allows us, if we're given a point on the circle and the radius, then we can go ahead and solve, if we're given the center point or a point along the circle, we can go ahead and solve and write the standard equation for that circle. This review is very important from the unit. These are all of the formulas that you should have down in your notes in order to be able to successfully finish your quiz. Thanks, guys.